And it's only true under those conditions, but that's just often the case. You can put your thumb over that, right? And now we have a linear expression in temperature. What about for the rate? I mean, sorry, for the material balance.
It depends on the term of CA, like if it's like squared or not.
Right. It depends on the rate law. Depends on the rate equation. So, for example, first order. Oh, sorry, it just hit me. The reason why we didn't need to specify epsilon was equal to 0 is because it's a liquid, and we neglect volumetric, we neglect that during liquids. I'm sure you were still wondering. So if you plug that into there, then the x that you get from the material balance is what we had on the board a second ago. Tau times the rate constant, but now I don't want to put rate constant. What do I put instead? So what is k equal to? Pre-exponential factor times the exponent negative EA over RT, right? I want the temperature to be there explicitly. And then this is 1 plus tau, same thing. What does that look like? No, I don't expect you to know that. It looks like this. Okay, so this is so what is the intersection? Yeah, that's the solution to my problem, right? One way to simultaneously solve two equations is to make a plot and see where they intersect. That's a solution. So this intersection point gives the x that I care about and the temperature that I care about. Any questions?
Is this a dumb question? I'm just asking, like, will it ever be that the plot? Well, it's a linear equation. Never mind. I was gonna say.
You're asking if they never, if they ever did not intersect. I don't think so. I mean, I can't imagine.
If it follows that function. Like,
That's not linear, so like it's not impossible if it would veer off in the other direction and have an intersection line, like it's actually coherent.
But I'm saying that if you did the problem correctly, that wouldn't happen.
Right.
Yeah, sure. I can write two mathematical functions that don't intersect.
Yeah, there are.
But I don't
there
think
are
that there's
fewer sets
actual.
that intersect, or is it intersect?
Yeah.
Like,
Does it ever have multiple intersections?
Yes.
desired, like higher, whichever one.
So that's a great question. So the question was, are there ever multiple intersections? Yes, there are. The question is not how did we choose, it's how does the reactor choose?
Well, if you run at a higher temperature one, like if you run it at the temperature of the second solution, it will hit the second one, right? Like would it just become a...
Well, I mean, it depends on how you're doing the reaction, but yeah.
Yeah, it'd be cost optimization, like how to make the
I mean,
temperature versus pure.
There are times where you have multiple steady state solutions to reactor problems.
But then how would you be able to influence which one is the actual choice? If it's, because you can only control the volume and the inlet temperature. I don't know how you would choose one of the
Startup conditions. There's ways of coercing it into one of the steady state solutions. But no, I mean, I think it actually does come up later in the class. I think we do talk about it for a lecture maybe. But there are times where there are multiple steady state solutions to reactor problems. Okay, any other questions? All right, we're going to wrap up for the day.